Welcome to the Other Alternatives section of Introduction to Renewable Energy. In this section, we'll be talking briefly about biomass, biofuels, hydro systems, and geothermal systems. There are other ways besides solar, water, photovoltaics, and wind to get the fuel you need from renewable sources. These alternatives include biomass, biofuels, hydropower, including microhydro and hydroelectric plants, and geothermal for electricity and for heating and cooling. So let's start with biomass. First of all, what is biomass? Biomass is any organic matter available on a renewable basis that can be used as an energy source. This would include wood and wood wastes, agricultural crops and wastes, seaweed and aquatic plants, animal wastes, and municipal and industrial wastes. Biomass is a fuel source that is part of the carbon cycle and therefore is considered to be renewable. But depending on the type and method used, it may still contribute to global climate change if the natural carbon equilibrium is disturbed. Carbon from the atmosphere is converted into biological material during photosynthesis. On decay or combustion, the carbon goes into the atmosphere. Biomass can be turned into usable fuel through 4 different processes: fermentation, conversion, combustion, and bacterial decay. Fermentation can take place using yeast. If you've ever made homebrew beer, you know this process well. Yeast breaks down the plant starch to make alcohol. Fermentation can also take place using enzymes. The enzymes can break down the cellulose in the plant's fibers to make alcohol. Conversion happens when biomass is converted into gas or liquid fuels by using chemicals or heat. Combustion can be one of 2 types, either direct or indirect. The burning of biomass to provide heat would be an example of direct combustion. Conventional combustion could be the use of residential wood stoves, fireplaces, masonry heaters, or pellet stoves. Indirect combustion would be the burning of biomass to produce steam to spin a turbine and make electricity. The environmental soundness of a combustion process would depend entirely on what you were burning. Pollution and contaminants vary by source materials. For instance, burning painted wood with mercury or lead, laminates with formaldehyde, bleached paper, or agricultural products with fertilizers and insecticides would not be a very sound practice. Many utilities burn waste and garbage. This may reduce the pileup of garbage in landfills, but we must remember that waste is toxic. Waste incineration is the largest known source of dioxin. Waste that can't be reused, recycled, or composted cleanly needs to be properly disposed of. When you burn toxic chemicals, you are essentially taking something that would have stayed put in one place and releasing it into the atmosphere to travel wherever it likes. Landfills will slowly decompose the trash and produce methane gas. Regulations nowadays require landfills to collect the methane that is produced, but in most cases, the methane is just burned on site. A more environmentally sound practice would be to collect the methane and use it to generate electricity. In bacterial decay, bacteria feeds on organic matter and produces methane. Methane is the main ingredient in natural gas. This process can happen with anaerobic digester. Anaerobic digesters are large sealed containers that decompose wet organic material without the use of oxygen. Methane can be purified and transmitted as natural gas. Next, we'll talk about biofuels. Specifically, we'll go over ethanol and biodiesel, the 2 most common types. So first, what is ethanol? Ethanol is a type of fuel that is made from plant matter and is therefore a form of biomass. Ethanol is most commonly produced through yeast fermentation of the sugar in the feedstock. First, the feedstock is refined to starch, then liquefied, fermented, distilled, and then dehydrated. This fuel is used in flex fuel cars and as E85, as well as being put in small doses in a mix of gasoline at most fuel pumps. The environmental benefits of this process depends entirely on the method and feedstock being used. Feedstocks that can be used include corn, sugarcane, barley, hemp, grain, wheat, wood, straw, and cotton. In the Midwest, it is commonly made from corn. Unfortunately, corn does not have as much sugar as other feedstocks. The net energy gain is pretty weak at 1 to 1.35, which means that for every 1 unit of energy put into the equation or process, you receive 1.35 units back. This is not as impressive of a conversion as, say, sugarcane, which has a net energy gain of 1 to 8. In Brazil, they've actually started using the waste from their sugarcane to produce 40 to 50% of their national fuel consumption. Another possible environmental problem with this process could be the impacts of overfarming. Practicing careful farming techniques would be essential to considering this an environmentally friendly practice. So next we have biodiesel. What is biodiesel? Biodiesel is a little more complicated, but essentially it is a type of fuel that is made from vegetable oil, so also a form of biomass. Biodiesel is most commonly produced by chemically converting vegetable oil through transesterification, which is a fancy way of saying that they chemically replace the glycerin ester in vegetable oil with a methanol ester. To replace the ester, you need a catalyst such as lye or potash. Biodiesel comes in a mix of diesel fuel anywhere from B5, which means it is comprised of 5% biodiesel and 95% diesel, to B100, which is entirely biodiesel. The reason for the mix is to avoid the complications of gelling. In northern climates, we get freezing times, which would turn the thicker fuel into a gel. Using a higher percentage of diesel fuel in the mix is advisable during the winter months. Biodiesel in the Midwest is usually made with soybeans. This means it will have a significantly better net energy gain than ethanol made from corn. The conversion rate of biodiesel made from soybeans is 1 to 3.2. This is because soybeans have a high oil content. The higher the glycerin levels, the better the conversion will be. Same as with ethanol, the impacts are dependent on the feedstock, which can be soybean oil, canola oil, mustard, palm oil, hemp, algae, tallow, or lard. Sometimes straight vegetable oil, or SVO, is used as a fuel, which eliminates the pollution caused by the lye or potash used. Using waste vegetable oil, or WVO, also increases the environmental benefits by closing loops. In order to use SVO or WVO, you need to renovate your system, your car or otherwise, so that there are two tanks of fuel, the vegetable oil tank and the diesel tank. This is again to avoid gelling. You can run the system on the diesel fuel until the vegetable oil warms up enough to become less viscous and flow through the system, at which point you can switch to the SVO or WVO. Switching back is also essential before turning off your engine so the diesel fuel can clean the pipes of all SVO or WVO. The environmental benefits, just as with ethanol, will also be affected by the farming methods being used. Hydropower is using already existing water systems for power. There are two types of hydropower systems: large dams for hydroelectric power plants, as well as micro-hydro systems. In large hydroelectric power plants, dams are created to develop a reservoir, which stores large amounts of water. The dam elevates the water, creating a drop. Water in the dam falls through a penstock to turn a turbine. A generator is turned by the turbine to produce electricity using the same principles as the wind turbine generator uses. Large hydroelectric systems provide large amounts of electricity over time. The systems in place now cover an area the size of France and provide about 19% of the world's electricity needs. However, large hydroelectric power plants have many disadvantages and problems. The dams that these systems need block the travel of wildlife. To account for this, many dams have what they call fish ladders, which is a path a fish can take to bypass the dams. The problem with these is that maybe the fish aren't quite as cognitive as the humans who created the ladder. Dams alter the stream flow, causing disruptions in the plant and animal ecology in an area. They destroy forests, agricultural lands, and recreational areas in the large reservoirs that they create. Recent reports have linked reservoirs to a significant release of methane from decaying organic matter that is exposed when the reservoir shrinks. The shrinkage also increases bug populations and disease. In contrast, with microhydro systems, you direct only a portion of moving water in a separate direction. You may have to manufacture elevation difference to create head, which is the difference between the level of the penstock intake and the turbine. There is significantly less of an environmental impact from microhydro systems than a large dam and hydroelectric plant. you are taking a small portion of the flowing water and would be less likely to kill off wildlife and plant life. This type of system has no water storage, which means that you may not have electricity producing when you need it. The amount of electricity may vary seasonally as well. Next, we'll discuss geothermal systems. Geothermal literally means earth heat. The temperature within the earth increases with depth. Geothermal can be used for the generation of electricity in some areas, can be used directly in some areas, and can be used in geothermal heat pumps everywhere. For the generation of electricity, geothermal can be used in dry steam, flash steam, or binary systems to generate electricity. In dry steam applications, steam is taken directly out of the fractures in the earth and used to spin a turbine. In flash steam, hot water is taken out of the ground. As it rises, it boils and separates to steam. In a binary steam process, hot water flows through heat exchangers to boil an organic fluid that spins a turbine. This type of system can only be used in areas that have this type of geothermal potential. It is not an option in the Midwest, as we don't have that type of geothermal resource. Direct use applications utilize geothermal heat without first converting it to electricity. This could be in hot springs or spa bathing, agriculture through greenhouses or soil warming, aquaculture, industrial uses such as product drying and warming, and residential and district heating. This type of system can only be used in areas that have this type of geothermal potential. It is not an option in the Midwest, as again, we don't have that type of geothermal resource. The option that works for everyone, regardless of location, is geothermal heat pumps, or ground source heat pumps. This type of system uses the constant temperature of the earth as either a heat source during the heating season or as a heat sink during the cooling season. For heating, heat is removed from the earth to the home. For cooling, the flow is reversed and heat is removed from the home and put into the earth again. It undergoes a compression, increasing the intensity of the heat during the heating season using the pumps. Geothermal heat pumps are effective globally. It takes less energy to move heat than to make it. So in that way, we are conserving energy. The ground source is an endless supply of energy, which makes the process renewable, and it can be used for heating and cooling. The environmental benefits of this type of system is contingent on the electrical source the process is replacing. The net energy ratio for this type of system is 1 to 2, which means that for every joule of electricity, the system will give off 2 to 4 joules of warmth. If the system runs on traditional power, which would mean coal in the Midwest, then you would be significantly reducing your carbon footprint by switching to geothermal. If a normal heating system would run on natural gas, you may actually increase your ecological footprint by switching to geothermal. That is it for this course, but if you want to know more about biofuels, you may want to check out AT105, Introduction to Biofuels.